In this video, we're going to talk about all the various properties of logarithms. So similar to what we experienced in exponents, we are going to have a series of properties that are going to help us, number one, simplify expressions and then ultimately solve some equations. The first thing we need to note in each of these properties is that m, the variable m, and a are positive real numbers, so they can't be negative. A can never equal 1. And r is any real number, so r can in fact be negative. And we'll use these three things, or these facts, to help us simplify some expressions. But first, we need to first start by actually identifying what the properties are and how they relate possibly to the properties of exponents. So we're going to start with the first four properties. The first one states that if you have log base a of 1, this equals 0. The second property states that if you have log base a of a, this equals 1. Now I am going to go ahead and briefly describe how these work, or better yet, how I know that these are actually true. So for the first two, I'm going to let the log base a of 1 equal x. So I'm going to assume I don't know what it's equal to. I'm going to let that be the variable x. I'm then going to go ahead and convert this into exponential form. So we have a to the x is equal to 1. Well, what value does x have to be in order for this to be true? Well, the only way in which you can get a value of 1 from this expression here, a to the x, is if x is equal to 0. For the second problem, we'll do something similar. We're going to say that log base a of a is equal to x. We will again put this into exponential form, so a to the x is equal to a. Well, a is simply a to the first. So then, using the fact that if the bases are the same, the exponents must also be the same or equal, then x must be equal to 1, which verifies that this is, in fact, true. The third property says that a to the log base a of m is equal to m. The fourth property says that log base a of a to the r is equal to r. What I really want to focus on with these two is the fact that you see the base here and the base here are the same. And when that occurs, then essentially your log and exponent are canceling out, so that all is remaining is what you're taking the log of. Similarly, with property number 4, notice how the base of the log is a, and what you're taking the log of has a base a, so then this simply becomes r. Okay? The fifth property says that if we have log base a of m times n, this equals log base a of m plus log base a of n. So in other words, you're taking that single log and you're expanding it to a series of sums. So this multiplication changes to addition when you want to expand it into numerous logs. Similarly, with probability number 6, you have log base a of m over n. So now we're looking at division. And you could probably guess, based on property number 5, that if we want to take this and expand this over multiple logs, so in other words that each variable in that division has its own log, you could probably guess that the division becomes subtraction. So this will become log base a of m minus log base a of n. And you can think of that similarly to what we experience in properties of exponents. How properties of exponents, when you're multiplying exponents, bases that are the same, you're adding the exponents, and when you're dividing, you're subtracting the exponents. So there is some correlation there. Number 7, if you have log base A of m to the r, this equals r times log base A of m. So in other words, your exponent here, r, becomes a coefficient, which can be written in front of your log. So then it's r times log base A of m. And the last one is that a to the x is equal to e to the x times ln of a. So one way to look at this one is, and I'm going to focus on the right side of this one, is to say that, well, this x can become an exponent based on our property number 7. So this is e to the ln of a to the x. And remember, think of ln and e as inverses since they both have base e. So they cancel each other out, and so what you're left with is a to the x. So you can think of it in terms of that when you're going ahead and evaluating e to the x times ln of a. For these two problems, we will use the properties of logarithms that we've just stated to help simplify this, or actually rewrite these in a different way. So we're going to start by supposing that ln of 2, the natural log of 2, is equal to a, and the natural log of 3 is equal to b. We are going to use these two properties, or use the properties from above, to rewrite these in terms of a and b, so that we no longer have any natural logs. All right, so the first thing we need to do, we really need to, our strategy is to actually break up what we currently see so that we have just ln of 2 and or just ln of 3. Well, right now we have ln of 2/3, and that's no good. So the first thing we're going to use is one of the properties that said that any logarithm with division can be broken up into subtraction. So it'll be the numerator minus ln, or natural log, of the denominator. Now we can substitute, because we know that the ln natural log of 2 is a, and the natural log of 3 is b, so that's my answer. Number 2, again, my strategy here is to try to break it up so that way we strictly have ln of 2 and or ln of 3. The first thing I'm going to do is change this radical, this fifth root, into an exponent. So this is ln of 6 to the 1/5. Well, we can then take one of the properties that tells us we can write the 1/5 as a coefficient. So ln of 6. So 1/5 times the natural log of 6. Well, you'll notice, hopefully, that 6 is the product of 2 and 3. So we have 1/5 times the natural log of 2 times 3. All right, so now we have our 2 and our 3, and we can then use this one of the other property of exponent. Sorry, we now have 2 and 3, and we can now use one of the properties of logarithms to break up that 2 and that 3 into their own individual logarithms. Now, be careful. When you do this, notice this is 1/5 times the natural log of 2 times 3. So in other words, when you're breaking this up, 1/5 needs to remain with both the 2 and the 3. So it'll be 1/5 times the natural log of 2 plus 1/5 times the natural log of 3. We now can rewrite this in terms of a and b, and so this can be 1/5 times a plus 1/5 times b, or another way to write this is to say 1/5 times a plus b.
Excellent.